Okay, we are behind schedule, so we can start. I hope you can hear me clearly. Please respond on the chat box if you can hear me. Okay, Azege is always here. Azege Joseph. Yes, you are always here in the class. I can see. Okay, okay. So today we'll be looking at past questions, some questions. I hope you can see the screen, the questions. Can you see the screen? Can you see the question? Questions? Yes, but it's not clear. Okay, I will read the questions out. So just have your paper and pen. I will read the questions out, and then you will give me your options. I will read the questions and the options, so you give me your answer. If the answer is A, you just type A, B, and in that order. So if you are ready, let me read the question. M, that is capital M, L raised to power minus 1, T raised to power minus, T raised to power 2 is the dimensional formula of, I take that again, ML raised to power minus 1, T raised to power 2 is the dimensional formula of A, force, B, coefficient of friction, C, modulus of elasticity, D, energy. I take that question again. Capital M, capital L raised to power minus 1, capital T raised to power 2 is the dimensional formula of A, force, B, coefficient of friction, C, modulus of elasticity, D, energy. Please need the answers. Be fast about it. Let's time ourselves. Then if you don't get it, I will tell you the answer and explain. Somebody says B. Akavtu Akewase says B. Any other option? Naz TJ B. Any other option? Any other option? Okay. Let's go for the answer. The answer is not B. The answer is C. Let me now explain why it is C. For those that are just joining, let me read M, capital M, L raised to power minus 1, T, capital T raised to power 2 is the dimensional formula of A, force, B, coefficient of friction, C, modulus of elasticity, D, energy. So the answer is C. The answer is C, modulus of elasticity. Like I said earlier, for you to know the dimension of a quantity, you must either know the formula or the units. When you talk about modulus of elasticity, that's what they call Young's modulus. Young's modulus, if you have pen, you can be writing it down. Young's modulus, the formula is tensile stress over tensile strain. Stress over strain, stress over strain, and stress is force over area. Stress is force over area divided by extension is, strain is extension over length. I take that again. Modulus of elasticity, or what we call Young's modulus. The formula is stress over strain, tensile stress all over tensile strain. So mathematically, we can say that Young's modulus E is equal to Young's modulus E stands for Young's modulus. E is equal to, the stress is F over A, that is force per unit area, divided by strain, which is E all over L, extension over length. So if you simplify that, you now have force all over A times L over E. So the formula now becomes newtons per meter squared. So that is the unit of modulus elasticity. So let's now analyze that. Newtons per meter squared. Newton is what? Force. Newton is force, and force is mass times acceleration. So you can say force times mass, that is force, which is mass times acceleration, or you can get a dimension of force. You can get a dimension of force as ml raised to power minus 2, L raised to power ml t raised to power minus 2. We have done this in the class. The dimension of force is ml t raised to power minus 2 Are you getting it? Are you getting it? We've derived the unit of elasticity as newtons per meter square. Newtons per meter square. So the newton is force, and the dimension of force is m L T raised to power minus 2. That is the dimension of force. Then what we are left with now is meters square, which is L square. So if you evaluate it now, you now have M L raised to power minus 1 T raised to power 2. And the answer is C. The answer is C. Please, if you have any problem with that, let me know. If you're not clear, I will explain again. If it's not clear, I can explain again. Please let me know if it's not clear, I can explain again. Explain one more time. The question reads, capital M, capital L raised to power minus 1, T raised to that capital T raised to power 2 is a dimensional formula. Okay, somebody say it's clear. It's a dimensional formula of A, force, B, coefficient of friction, C, modulus of elasticity, and D is energy. I said that for you to know the dimension of a quantity, you must either know the formula or the unit. So the unit of modulus of elasticity is newtons per meter square. And newtons is a force, and the dimension of force is M L T raised to power minus 2. Is that right? ML T raised to power minus 2, while the dimension of M square or meter square is L square. So divide by L square. So if you do that, you now have ML raised to power minus 1 T raised to power 2. So C is the answer. Question 2, 5 Fermi is equal to 10 raised to power 5 Fermi is equal to, Fermi is F-E-R-M-I. 10 raised to power 5 Fermi is equal to A, 1 meter, B, 100 microns, C, 1 Armstrong, D, 1 millimeter. I take that again. 10 raised to power 5 Fermi is equal to A, 1 meter, B, 100 micron, C, 1 Armstrong, D, 1 millimeter. Give me your options. Your options. Should I take the question again? 10 raised to power 5 Fermi is equal to A, 1 meter, B, 100 micron, C, 1 Armstrong, D, 1 millimeter. Here, someone say is A, chose A. Two percent chose A. Okay, let's look at it. What is Fermi? What is the relationship between Fermi and meters? What is the relationship between Fermi and meter? 1 Fermi is equivalent to 10 raised to power minus 15 meters. 1 Fermi, I hope you are writing it down. 1 Fermi is equal to 10 raised to power minus 15 meters. 1 Fermi is equivalent to 10 raised to power minus 15 meters. So 10 raised to power 5 Fermi will give us how many meters? 10 raised to power 5 Fermi will give us how many meters? I take that again. 1 Fermi is equivalent to 10 raised to power minus 15 meters. So 10 raised to power 5 Fermi will give us how many meters? So in this case, 1 Fermi is equivalent to 10 raised to power minus 15 meters. So it means we are multiplying. We only multiply when you are converting from a. So if you multiply 10 raised to power 5 times 10 raised to power minus 15, then you have the answer will be 10 raised to power minus 15 meters. Minus 10 meters, rather. Let me come again. 10 raised to power 5 Fermi is equivalent to dash A 1 meter, B 100 micron, C 1 Armstrong, D 1 millimeter. So the approach here is 1 Fermi is equivalent to 10 raised to power minus 15 meters. So converting 10 raised to power 5 Fermi, we multiply. I told you when to multiply and when to divide. So in this case, we multiply. And if we multiply 10 raised to power 5 by 10 raised to power minus 15, we now have 10 raised to power minus 10 meters. So what is now the 1 Armstrong is equivalent to 10 raised to power minus 10 meters. So the answer is C. The answer is C, not B. The answer is C. Two people say A, one person say B. So the answer is C. Number 3, radians per second is the unit of A, angular displacement, B, angular velocity, C, angular acceleration, D, angular momentum. Question 3, radians per second is the unit of A, angular displacement, B, angular velocity, C, angular acceleration, D, angular momentum. Your answer is needed. I take that question again. Radians per second is the unit of A, angular momentum, A, angular displacement, B, angular velocity, C, angular acceleration, D, angular momentum. I need answers. Let's be fast so that we can cover. Obed Younger says B. Any other option? Azege says A. Inaz B. Any other person contributing? It's only 3 people that are making efforts here. I will have 10 up to 10 people here. Ongo Z B. I need one more answer before we go. I have between A and B here. So what do we choose? The radians per second is the. I keep on telling you that the answer a capsule. There was to say is A. Okay, listen now. Listen. Radians per second is the unit of A. Angular displacement, B. Angular velocity, C. Angular acceleration, D. Angular momentum. The answer is B. Angular velocity. Angular velocity, when we treated circular motion, we say angular velocity omega is theta all over t. Velocity omega is equal to all over t. That is the formula for angular velocity. And the unit is radians per second. So the answer is B. Are we there? So let's look at question 5. Let's look at question 4. What is the unit for measuring the amplitude of a sound? What is the unit for measuring the amplitude of a sound? The question is, what is the unit for measuring the amplitude of a sound? Question 4. What is the unit for measuring the amplitude of a sound? A. Decibel. B. Column. C. Hum. D. Circles. I repeat the question again. What is the unit for measuring the amplitude of a sound? A. Decibel. B. Column. C. Hum. Hum is H-U-M. And D is circles. Your options, please. Somebody says C. What is the unit for measuring the amplitude of a sound? A. Decibel. B. Column. C. Hum. D. Circles. Two people say C. I need more answers. More answers. Peace David Shahu says A. Okay, let's continue. Number 4, repeat the question again. What is the unit for measuring the amplitude of a sound? A. Decibel. B. Column. C. Hum. D. Circle. Please, the answer is A. Decibel. Decibel measures sound. Column measures charges. Hum Then circles, you talk about frequency. So the unit is A, decibel. I hope you are taking down this. I hope you are taking notes. Number 5. The displacement of a particle moving along x-axis with respect to the time x equal to at plus bt square minus ct raised to power 3. The dimension of C is, I repeat that again, I repeat that again. The displacement of particle moving along x-axis with respect to time is x equal to at, these are small letters, x equal to at plus bt square minus ct raised to power 3. I take that again. The displacement of a particle moving along x-axis with respect to time is x equal to at plus bt square minus ct raised to power 3. The dimension of C is A lt raised to power minus 2, B t raised to power minus 3, C lt raised to power minus 3, D t raised to power minus 3. I take that again. A question for the last time. The displacement of a particle moving along x-axis with respect to the x with time, I repeat that again, the displacement of a particle moving along x-axis with respect to time is x equal to at plus bt square minus ct raised to power 3. The dimension of C is A lt raised to power minus 2, B t raised to power minus 3, C lt raised to power minus 3, D t raised to power minus 3. Your option, please. Your option, please. Okay, the equation again. I repeat that question again. The displacement of a particle moving along x-axis with respect to time is x. All these are small letter x equal to at plus bt square minus ct raised to power 3. Options. The question is the dimension of C is A lt raised to power minus 2, B t raised to power minus 3, C lt raised to power minus 3, and D t raised to power minus 3. Your options, please. Somebody says B. Someone says B, more options, more answers. Seems you don't have a. This is still dimensional analysis. This is under all these questions are under units and measurements or units and dimensions. So this is under dimensional analysis. This is an equation, and that equation is x equal to at plus bt squared minus ct raised to power 3. We have the left hand side of the equation, which is displacement and is L. So the right hand will also have a component of L. But the emphasis here is ct raised to power 3. That c stands for L all over t raised to power 3. So, okay, the options. Somebody said I should help with the options. The option is LT raised to power minus 2, T raised to power minus 3, LT raised to power minus 3, and D is T raised to power minus 3. Should we go on or wait for you for your answer? We are still waiting. Say taken, sir. Okay, the answer, let me explain. That equation is x equal to at plus bt squared minus ct raised to power 3. And the answer, the question is the dimension of C is what? So on the left hand side, we have the displacement, which is L. So the each term on the right hand side of the equation will have that component. A, B, C stand for the displacement on the right hand side. So if you have C all over t raised to power 3, that becomes LT raised to power minus 3. So the correct answer is C. The correct answer is C. So we're moving to another section which is under vectors. Let's look at this number. Number 1. What is the maximum possible number of components of a vector can have? What is the maximum possible number of component of a vector can have? What is the maximum possible number of vectors a component of a vector can have? Okay, later I will go back to that number 2, enhance. Later I will go to the question. So let's look at this one first. The question is, what is the maximum possible number of components a vector can have? What is the maximum possible number of components a vector can have? A, 2, B, 3, C, 4, D, any number. What is the maximum possible number of components a vector can have? A, 2, B, 3, C, 4, D, any number. I need your answers. Somebody say B. Please understand the question first. What is the maximum possible number of components a vector can have? A, 2, B, 3, C, 4, D, any number. I have B and C as options. I just hope you are taking down these questions so that they can revise last time. What is the maximum possible number of components a vector can have? A, 2, B, 3, C, 4, D, any number. Do we wait for more answers or continue? What is the maximum possible number of components a vector can have? A, 2, B, 3, C, 4, D, any number. Okay, the option here is D. The correct answer is D. A vector can have as many components as possible. Vector can have 2, 3, 4, can have more than 4, can have any number. So the correct option is D. So next question, which of the following operation with two vectors can result in a scalar? Which of the following operation with two vectors can result in a scalar? Which of the following operations with two vectors can result in a scalar? A, addition, B, subtraction, C, multiplication, D, none of the above. I repeat the question again. Which of the following operation with two vectors can result in a scalar? A, addition, B, subtraction, C, multiplication, D, none of this. I need your answers. I need your answer. Repeat the question for the last time. Which options with two vectors can result in a scalar? A, addition, B, subtraction, C, multiplication, D, none of this. Any option? Are we together? I need answers. Somebody say multiplication, somebody say A, somebody says C. The options in this thing, you need to give the options, the letters. A is addition, B subtraction, C multiplication, D none of this. So the correct answer is multiplication. Multiplication. When you multiply two vectors, they will give you a scalar. When you multiply two vectors, they will give you a scalar. So the answer is C. So again, which of the following operations with two vectors can result in a scalar? A. Addition. B. Subtraction. C. Multiplication. D. None of this. So it's multiplication. When you multiply two vectors, they will give you C. So we'll proceed. Next question. The acceleration of a particle performing uniform circular motion is A. The acceleration of a particle performing uniform circular motion is A. Omega square over r, B. 0, C. VR, D. V square over r. I take that again. The acceleration of a particle performing uniform circular motion is over r, B. 0, C. VR, D. V square over r. Your options, please. Azege says D.